Okay, let's get started. Thank you for attending. What I'd like to talk about today is how to practically get 3D EM simulations into planar circuit software. And the problem is right there. You have planar circuit simulation environment, layout environment, and yet you want to do 3D EM simulation. So let's get into it. Okay, here is the typical type of circuit that is a challenge for a designer. You can see we have a mimic here, bond wires over to some kind of module, various interconnect structures on the module. In this case, we have some chip caps on the surface. And we want to control all this from the circuit environment. And in particular, this designer, in the course of making their mimic and their module, they might, for example, want to send this spiral out to a planar simulator. In our case, at AWR, we would use Axiom, our planar simulator. Sometimes over here, not our topic today, they actually did this with a product we have called ACE, which actually you can draw the lines very quickly, putting in all the correct stack-up rules, etc. And it actually makes a little model for this. And the third case they might want to do is over here with these bond wires, they might actually want to do a 3D finite element simulation. And what I want to talk about is how you can easily do that. The way not to easily do that would be to copy all those shapes into an external 3D simulator, essentially redraw it, simulate, import the S parameters, and go from there. See if we can do it a better way. As part of the solution, what you really want to do is from the schematic, and you see a typical schematic here, you want to actually be able to extract this schematic's layout automatically into various simulation tools. And we do that in our software through an extract block. And for example, here we go off to the planar simulator Axiom. Again, not our main topic today. You could go off to ACE, which I mentioned before, which actually makes a model for you. Or, as of now, we can actually go to a 3D simulator. Before I get into the details of how that works, let me explain Analyst. This is our newest product. It's in beta right now. Will be released in a couple months. Our booth is right over there. If you want to get a full demo of it, feel free to drop by. It is a 3D finite element program and supports all those good features that you are used to. We support wave ports, internal ports, differential ports, terminals if you have differential pair lines on the wave port. So for those of you used to other 3D simulators, I think you'll find it very familiar. And I won't go through the details. Of course, we have various field visualization properties. Again, pretty much standard stuff for those of you used to these simulators. The thing that is unique to Analyst is actually it's tightly integrated into our environment, and that's what I want to focus on. So first of all, quite frankly, for those of you who use our software and have used things like Axiom, the planar solver, a lot of this is going to look really boring. And we made it that way. We don't want it to be exciting. You're going to go, I've been demoing this morning in the booth, and I've literally had people go, that's Axiom. I go, no, if you look carefully, there's a box. It's actually Analyst. It looks almost exactly the same. So in terms of starting with your schematic and extracting, you literally just change the simulator to Analyst from Axiom. Now, there are some differences. When you have a planar simulator like Axiom, you have no boundary. It's an infinite domain, okay? Obviously, in a finite element piece of software, you have to have boundaries. And the way we do that in our software is when you create the Analyst structure, you can see this simple T right here, you can also draw the boundary. Now, of course, it creates a default of a box, but you are perfectly free to change the shape of that boundary. You simply draw the shape, say this is the boundary, and you're done, okay? You can support on the boundary conditions on the sidewalls, various boundary conditions, everything from absorbing boundary conditions, perfect magnetic walls, perfect electric walls. Again, all the standard types of things you would expect. Another thing I'd like to point out with Analyst when they drew this, notice that these ports go to the boundary, right here and right here. In Analyst, if a port goes to a boundary, it automatically becomes a wave port by assumption. So there's no need to say this is a wave port, etc. It will go to the boundary, it's a wave port, it's done. It will pick the right number of modes, in this case one propagating mode, and you're done. If you can also have a port inside the structure, that is automatically an internal port, okay? So again, we're trying to set this up so you, the user, are not doing a lot of drawing, you're not doing a lot of setup. Another new feature that Analyst has that you have to do with the 3D tool is you can have finite dielectrics. Now, with a planar tool like Axiom, that concept doesn't exist. All the dielectric layers are infinite in extent. They have to be. With Analyst, you can see this little dielectric resonator. You can simply draw a shape, extrude it upward or downward of a certain thickness, and you make it a dielectric material, and voila, you now have a finite dielectric. Another example of this sort of thing would be if you had a module, say LTCC or something, or maybe a Droid board, you're cutting a hole in it to sink the chip down to get to the heat sink, right? And you would do the same sort of thing. Okay. Now, if you're going to make a 3D tool easy to use in this type of environment, one of the big things you've got to deal with is things like bond wires, BGA balls, ground straps, tapered vias, etc. You do not want to be drawing these things, okay? As you can imagine, it's painful if you've ever had to do it. And in our software, in our environment, you don't draw them, okay? So what we do, if you look at the schematic of this thing, you will notice these three bond wires here. These are actually P cells. Now, a P cell in general, like this guy, this transmission line, a P cell has layout, and the P comes from parameter. As you change the width and length, the layout changes. All right? Well, guess what? We now have 3D P cells. Okay? So when you want that bond wire in Analyst in 3D, you don't draw it. You just simply put down a P cell, and you're done. How do you change the length of these bond wires? In the layout, you just simply grab them and you move them. You can stretch them, move them around, and you're done. Again, the whole focus here is completely integrated into the circuit environment, yet a 3D simulator, and yet you're not sitting there drawing and torturing yourself with all these setup conditions as much as possible. Okay? Now, another thing that we have brought out with the new version of the software, and this also works in the planar solver, the Axiom solver, and Analyst, both, is we have introduced parametrized EM layout. And what you're seeing, this is an example of this. It's a via going through several layers. All these, here's the EM layout, and you see all these rather cryptic looking symbols over here, writing, especially text that small. These are telling the hole how big to become. So this is making a hole through all the layers, etc. And all of that hole size through those layers is controlled by one parameter here on your schematic. So now, and in this case, we're sweeping this hole size over a number of sizes, and you create an EM model which has those various sizes done for you. Okay? So in conclusion, you want to get 3D to work in your planar circuit solver stuff. You do not want to be firing off a separate 3D tool, running over, drawing the geometry or exporting the geometry, doing all the 3D stuff, getting the S parameters, bringing them back in, and trying to get it to work. Never works, you got to do it again. It's a real pain. It turns out that for you as circuit designers, when you use 3D EM tools, what are you using them for? 90% of the time, it's quite frankly standard P-cell shapes. It's a bond wire. It's a BGA ball. It's a BGA grid. It's a ground strap, a bond strap, etc. Okay? There are very few of these shapes that normally most of you are ever going to work with. So stay in the environment, the circuit environment. Throw in those shapes into your schematic. You don't have to draw them. And then you automatically are doing the 3D in the environment, including finite dielectrics, arbitrary sidewalls. Now, the final thing I'd like to say on this to conclude is, what if you have a structure that doesn't fit into that world of, P-cells and essentially planar shapes? We also have, or will have shortly, an external editor. So if you want to, let's take an example of an SMA connector, okay? And an SMA connector, of course, has a round barrel, etc. So it doesn't fit in very well to layers. You can go into the external editor, draw it, parameterize it, and essentially make your own P-cell, which you can then use in the software. So I don't want you to think that you are constrained by this. It's just I think you'll find about 95% of the time this will work fine, not requiring you to redraw, and now have the capability of 3D EM simulation for those portions of the circuit where you need it. If you're interested in the details, please check us out. We're in the booth next door, and have a great show, everyone. Thank you.